Hello again, everyone. One of my students recently has asked me to show this as a video, and I thought I'd make it available to everyone. So the question is that we have two planes. So that's plane with the equation x plus 2y 3z equals 5, and the other plane which is 2x minus y plus 2z equals 7. And we want to find the equation of this blue line. So of course that blue line goes, and these planes aren't just as it's shown here. The plane is a plane and it goes in every direction. But it's customary that they show a plane as a parallelogram, and so we want to find the equation of this line. So looking at the equation of the two planes, you can see that we can show the normal vector to the first plane, so this one. So the normal vector to this one is obvious from its equation. And so the normal vector to that plane would be 1, 2, and 3. So you get the information from the equation. So that's 1x, that's 1. 2, that's 2y. So, and then 3, yeah. And the normal to the other plane, so the normal vector to the other plane, let's do this one in red. So if I can draw it as normal as I can. So this one would be, from its equation, it would be 2 minus 1 and 2. So as you know, the normal vector to a plane is actually normal or perpendicular, basically perpendicular to every line on that plane. It doesn't matter where the line is. This pink vector will be perpendicular or normal to every line on that plane, including this blue thing. And this red one also would be perpendicular to every vector, every line in this plane, including this blue, which is also in this plane. So this line, this blue line, belongs to this plane as well as this plane. That's where the line of intersection is. So one important finding here is that both of these vectors, the red and the pink, they're both perpendicular to this line, which means the direction of this line is such that it's perpendicular to both of these. And that direction, or that vector, can be found by doing a vector product of these two. So vector product sometimes is called the cross product. Yeah, and to find the x component of this multiplication, you do so basically you exclude the x of the two vectors that you're multiplying, and the x component would be that multiplied by that. So just like finding a determinant. So is that times that, take away that times that. So that times that's 4, take away minus 3, that would be a plus 7. And to find the y component of it, so the y component of this vector, or the j component of it, would be by excluding these two numbers and doing the determinant between these. So it will be 1 times 2, take away 3 times 2, and then we negate it because that will be the middle component. So that will be 2 take away 6, that's minus 5, but we would negate it, so you get positive 5. And then finally, to get the third component, or the k or the z component, you ignore these two numbers and you do the determinant between the remaining numbers over that times that, take away that times that. So that's minus 1 and minus 1, and then take away 4, and that would be minus 5. Yeah. Did I make a mistake here? Let's just check to see if I made a mistake in the second one. So that's 2 take away 6. That's 4. Yeah, so that's 4. 2 take away 6. So that will be minus 4. So that changes to positive 4. So that's the direction. That's the direction of this blue line, because this blue line is such that is perpendicular to both of these. And then when you cross multiply the two vectors, you find you find a new vector which actually is perpendicular to both of these vectors. So really that vector is the same direction as what this line is going in. So I have a direction vector for this line. The only thing I need to be able to find an equation for this line is to find a point on this line. Yeah. So as you know, this line is made out of billions of points, and so therefore the two plane actually share many points between themselves, and I'm wanting to find one of them. So it's not as if I'm finding one point. I'm finding one point out of many possible points. So to do that, I'm going to solve these two equations simultaneously. So solving these 2 points simultaneously is 2x minus y plus 2z equals 7. And then we got x plus 2y plus 3z is equal to 5. Now, as you know, when you have more equations than variables, so here we got 1, 2, 3 variables, but we got only 2 equations. So we got more variability, more flexibility in this setup than we have restrictions, which are the equations. So since we got more variability, it allows us to play around with this variability, which is basically suits the fact here that we are finding one point out of many points. So that really, to solve a situation when you have more equations, you have more variability than equations, is to set one of the equations as you randomly wish it. So I'm going to make z equals to 0. It's quite customary that we make the third one equal to 0. It just makes the setup and working through it easier. So we'll make z equals 0, which will then reduce these two equations to 2x minus y is equal to 7. And it also makes the second one to be 2 plus 2y equals 5. So I'm just going to multiply the top. I'm going to multiply the top equation by 2. So I get 4x minus 2y is equal to 14. And it would be x minus 2y is equal to 5. So if I add these two equations together, I get 5x is equal to 19, which means the x of the point where these two will meet would be 19 over 5. So since we got the x and we now have z, we can go and find the y. So why don't I just use this to find y? So we got two x's, which would be 38 over 5 minus y is equal to 7. So this means that y, lock this to lock some to me. So so y would be equal to 38 over 5 minus 7. So that's 35. So 38 minus 35. Yeah. So that would be 3/5. So that's y. So the point where the point, this red point here, this red point has it has the position vector of x was 19 over 5 y was 3 over 5, and z was 0. Yeah, so we have the direction vector. So this is the direction vector, and that's the point. So I'm just going to copy these two pieces of information, bring them down to write the equation of the line. So I've got the direction vector and a point of the line. So as you know, the equation of the line would be the point, one known point, so that's 19 over 5, 3 over 5, and 0, plus lambda or t or s, and the direction 4, 7, 4, and minus 5. So that's the equation of the line. Yeah, we could actually straighten this equation, but that is just as good. So the conclusion was that what we did was, quickly, just to go over it quickly, we multiplied this vector by this vector, cross multiplied, that's vector multiplication, and that would produce a vector which is perpendicular to both of these, which is exactly what this line is capable of being. This line is perpendicular to both of these. And then we found a point, a single point on this line, by doing a simultaneous equation between the two planes, and then having a point, having a known point of the line, as well as its direction, we wrote the equation of the line where the two planes intersected. Okay, well, don't forget to send your comments to me, as well as if you got any outstanding and difficult questions where you want me to make videos and put it onto my channel. I will do them in the sequence that they will arrive. See you in the next video.